moving. And now we do arterial flow. This is the fast flow. And unfortunately, it looks like the arterial has enough shear force to overcome that phenotypic difference because we lose the hyperactive phenotype in our Layilin knockout. Speed overcomes phenotype difference. And then again, we have our arterial collagen, and we actually saw a little difference here. This was interesting. There was a difference. We just didn't know how to pursue it with all of our, preceding data and then the data that comes after this. But something with the collagen might be happening for arterial flow. And again, this is what you would have in arteries. Unfortunately, for the purpose of the paper, we could not pursue it, but there was a little something there. So now we are looking at GTPases. So, and GTPases. These are the on and off switches, and Layilin again has been shown to be linked to GTPase activation. So A through C, these are all G-LISA assays. What you need to take from this is that the higher the absorbance measured here, as time increases across the x-axis, the higher the absorbance, the more of the activated form of the GTPase. Let me erase that again just for clarity. Think of it as the higher you go, the more active the GTPase is. And that's true across for B, A to C. And what's exciting is that our red, which is our Layilin knockout, consistently is showing a hyperactive phenotype, in that the RAC1 across here is, again, it's above wild type up to a point, and that's true for all of this. But in the early stages, there's more of the active RAC1 here. Same for the row A. Early stages here, it's much more active compared to the wild type. And then we have another small GTPase over here. And again, we have this hyperactive phenotype well above the wild type. And this was so exciting for us. What about for this one over here? Well, RAC1 is the most quote-unquote druggable out of all of the GTPases that we were looking at. It's easy. It's one of the easiest to study as well, just because there's so many more ways to measure it. And so that's why we went after RAC1. And so here we are measuring what happens when we target RAC1 and inhibit it. And what we predicted was that our Layilin knockout would be resistant to that inhibition. And lo and behold, as we were stimulating it with, again, thrombin, and we're measuring the activation of Ajanel A, as we increase the inhibition, our wild type right here is appropriately being, inhibited. But our Layilin knockout in red, here and here, is resistant to it. This is really exciting. Well, let's go to another position. Let's go to something that's downstream of RAC1. So we then looked at PAC inhibition. What happens when we inhibit the PAC protein, which, if you remember from the animation that I showed, RAC1, when it's activated, then phosphorylates PAC, which would then lead to the activation of integrin. And unfortunately, when we were inhibiting this, we did not really see a difference in the wild type versus Layilin knockout. What this just tells us is that this is too far downstream. Whatever Layilin is doing to mediate this pathway, it's upstream of PAC. I'm going to move this again. And finally, we have our Western blot. So we have here resting platelets versus activated platelets. And again, wild type versus Layilin, wild type versus Layilin. Really, if we look at the activated here, we really do not see much of a difference. Real difference. If you're wondering what vinculin is, this is our control. Actually, let me control. This should, again, not change between our samples. And this bar is incredibly similar to this bar. This bar is similar to this bar. This bar is similar to this bar. So I'm not going to spend too much time on the activated side of this. However, the resting is where the money is at. So we're looking at the total amount of RAC1 here. And what's great is that the wild type and the Layilin knockout have very similar RAC1 protein levels. But when we look at the activated form of this, look at that. When they're just resting and they haven't been activated, there is more of this active RAC1 sitting in the platelets. This is so exciting. All right, then we look at this P-Merlin here. This is the phosphorylated version of Merlin. This was, unfortunately, Merlin gave us a really hard time with the Western blots, but we can still appreciate that there is more of this phosphorylated version of Merlin in this Western blot. And this is all representative of like 3 mice each. So 3 Western wild type versus 3 Layilin knockout. We are just showing the nicest ones for this. And what's important here is that there is more of this P. Merlin. And remember, P. Merlin equals off version of Merlin. And remember, Merlin turns off RAC1. So you have turned off the off switch here. That's important. Okay, we also had the ability to look at another GTPase called RAP1. RAP1, again, we have similar amounts of the total amount of RAP1, but look at how much of the active form there is just sitting around in the Layilin knockouts. What this whole figure is showing us is that the Layilin knockouts they are primed to activate. And then even down here, remember, PAC, when it's activated, it will then activate integrin. And we just have them in different form. That's why we're not all the way up here. But we still have our wild type Layilin resting, activated. Look at this. There is so much more of this active form of PAC1. So this GTPase pathway that we have here is already primed and ready to go in our resting knockouts, which probably explains our hyperactive phenotype. So this whole figure, let me zoom out. So this whole figure is showing that Layilin mediates platelet GTPase activity. That's what this whole figure is showing. And it's a lot. All right, next. So this is the final figure. And this is where the money-making figure is. So I'm going to zoom in on here. Here we go. So first, let's start with A. These are microvessels. And what we're seeing here is a healthy person, healthy donor, and an IBD patient. And when we are staining the inside of here, this is clear. It's healthy. You should not be sick. But here we have clots. As you see here in the middle here, that is clots, or the quote-unquote microthrombi or microvascular thrombi. And that's all quantified over here. So again, healthy donors, IBD. Look at how much more clotting there is. Fantastic. But remember, this is a whole paper about Layilin. There has already been literature covering, hyperactive platelets in IBD. That is a hallmark of IBD. So that's really what just A is saying, is that platelets equal hyperactive in IBD. That was already really known, but you always want to show that in your own data. Now we need to go, okay, with those hyperactive platelets, what's going on with Layilin? And this is the Western blot here. We have Layilin on top and a control on the bottom here. And we can just see in this one, there's a reduction of Layilin, which is again quantified down here. Look at how much less Layilin there is. Now, it's not a complete deletion and it's not a complete loss, but these hyperactive platelets, IBD platelets, they have reduced Layilin. Coincidence? I think not. All right, now this is in mice over here. So we have our healthy control. Well, yeah, these are healthy controls. This is DSS, and these are all in wild type. We didn't bring in the Layilin knockout for this one because we were just trying to show what happens in diseased mice. And again, look here, we have a reduction of Layilin, which is quantified down here. Look at this. Look at this. When you induce DSS or when you induce colitis in our mice, your platelets have a reduction of Layilin. Woo! So already looking good in our models. Let's continue on. All right. So we have D and E. These are G-LISA assays again. And this is measuring the active form of RAC1. And these are all in resting. It was going to be hard to do this specific experiment in if you activated it with thrombin. So we just looked at it at resting. And what is shocking is that our IBD patients had so much more of this active RAC1 just sitting in their platelets. Like we were not expecting this. We were hoping for it, but the amount that we saw here was wild. All right, and then with IBD patient platelets, you can actually separate them into remission versus active disease. And so we're like, okay, is there a huge difference here? And we can actually appreciate that remission had the statistical significance here. Active it actually has an impressive spread compared to the healthy donor. The only problem is that mathematically we can't say it's statistically significant because of how freaking big this spread is. But we can, just by eye, we can appreciate just how much more active RAC1 there is, even when we separate it out with remission and active. Now here we have RAC1 inhibition. Our thought process was like, okay, so we think, much like our mice, if we have this active form of RAC1, then our IBD patient platelets, kind of like our Layilin knockouts, will be resistant to inhibition. So we're again measuring integrin activation here using PAC1. And this is a little different from previous y-axes, but the idea is going to be there. The higher you are on this axis, the more inhibited you are, or the platelets are. What shocked us was that, unlike the mice, when we increased the EHT concentration here, we actually saw an increase in inhibition. They were more sensitive. So that was unexpected. While this seems counterintuitive, this is still a hallmark of GTPase dysregulation in these platelets. So that still hasn't changed in these platelets, but the fact that they are sensitive to this drug, this EHT drug, well, does that mean that that's a possible drug for future studies? So, I'm going to move this. All right. So here we have, again, another flow cytometry. And these are in mice. Once again, we're going in mice. And what we did here was, this was a 7-day DSS colitis model. And what we did was we treated them either with saline or with EHT. The reason why you don't use water for this is because that, you put in liquids that are at the same pH and salinity as your blood, which water is not, but saline is. And that's why you get a saline drip. If you go to the hospital, you don't get a water drip. That's deadly. So at the end of this 7-day colitis, after 7 days of DSS, we then took the blood and then we stimulated it with thrombin again. What we're trying to see is, does EHT actually help colitis? Because here's the thing. We can't just do that on humans. We can't just be like, here, give you a drug for EHT. We can't do that. That's illegal. But we can do it with mice. What's exciting here is that when we added EHT, and that's in violet here, we had a reduction of Ajanel A, of that integrin activation. That's exciting. Unfortunately, when we add enough thrombin, they're very similar to each other. It overcomes that difference. But at the lower ones, there seems to have been a good change here when we add EHT. Now, what we did was we took those same mice and then we look at their histopathology. What that means is that we look at, measure how sick they are. How sick their guts are. And that'll be shown in eye. But what we did was we really sat around a table. There was 4 of us, and I was not blind to the measuring, but everyone else was. And they, on a very strict criteria list, they measured everything and they said this is how sick I is based on these criteria. And EHT was, again, consistently lower in this score, which means that they were healthier compared to those that were just saline treated. Let me look down here. Let me just quickly readjust. So this is what we were measuring. So this is saline treatment and this is EHT treatment of, again, those same mice from up above. All right. There's a couple of things that you're looking at when you're doing this scoring. First off, you are looking at how well does this gut stay together. This, what I'm showing right here, is a very sick gut because if you look here, you've lost your crypt structures that are normally in your gut. And then you're looking at the thickness of this violet line right here. You're looking at the thickness of it. The thicker it is, the sicker you are. And also the less defined it is, the sicker you are. And unfortunately, I'm going to erase that just because there's going to be so much drawn on this that it'll be hard for you to see. Okay. Next, what this arrow is pointing at right here are the dots. And the dots, immune cells. The more dots there are, the more immune cells have been brought to that location and the sicker you are. And then you look at submucosal swelling, which is how much swelling is in this section right here. This is a lot. This is a massive amount of swelling. This is an incredibly sick colon right here. However, when we look at EHT, we can appreciate how much healthier this looks. Like here, we're looking at, again, this side here, and we have a very good border here. You can actually see some of the crypts really well, which are these little areas right here. It's still sick. The crypts are not perfect, but like unlike over here, again, if we're going to look over here, like huge difference. And then we look at this, again, look at this line right here. This barrier, it's more defined and it's not nearly as swollen. You can also look at the number of immune cells over here. And again, not as many dots, so not nearly as sick. It's still sick, but it's been reduced. And then we also look at the submucosal swelling. When you erase this a little bit, just again for ease of watching. And look at this. It's not nearly as swollen. Look at that, look at that, look at that. Now, I do want to say here is that, yes, EHT is healthier. It doesn't cure the colitis, though. So that you're never going to see a perfect cure for this. All right. And if you're wondering what L means the luminal space here. Because when you have your gut, you have your little areas, and then the space in between that food passes through, your defecation will pass through. That is your luminal space. And then S is your submucosal, which is what we were measuring for the swelling here. That's what this is. Let me zoom out. So this whole figure is looking at two things. One, IBD, hyperactive platelets have reduced Layilin. So in a human model, a lot of our previous mouse model stuff holds true. And then we have two, inhibiting RAC1 improves colitis symptoms, or at least the few that we saw. there just was not going to be enough for us to measure like every single thing. Oh, I also want to make an addendum here. This is not 7 days. This was 5 days. We were afraid that if we went for full 7 days, we couldn't go out for the full 7 days because the sicker the mice get, the fewer platelets they have in their blood. So we had to make a call. So we only did 5 days. So yeah, those are the paper's figures. So here is a quick schematic summary of where Layilin fits into platelet PAR signaling. Here we have thrombin, which is going to be stimulating this PAR receptor, which will then lead to the eventual downstream activation of a GTPase. However, when Layilin is present, it is able to bind to HA, which then has it bound to Merlin, which then can cause this to turn off this pathway. Remember, Merlin is the off button for GTPases, which means that PAC1 and PAC2 never get activated. However, when Layilin is absent, we have the same stimulation with thrombin, and our GTPase starts to be turned on, but note that there is no Layilin to bind to hyaluronin. There is no binding to HA, which also means that there's no landing site for Merlin. And we have this pathway proceed as it should, and we also have PAC turning off Merlin, which turns off the off button, so this is able to continue going. That's where the hyperactivation comes in, and that's where you get this change in alpha-2 beta-3 activation. So, we've talked about what my paper has ultimately shown, but now let's talk about what it leaves to be explored. So the first one that we can talk about is this. What does Layilin and HA do to GTPases in healthy platelets? For context, remember that my paper focuses a lot on inflammatory bowel disease. And there's a lot of good reasons for that. The main one being that reduction of Layilin was found in IBD platelets, and so it made sense to study it in the original context that we noticed it in. However, there's a ton that we can talk about for healthy platelets. I didn't get to do a lot of the experiments on healthy platelets past the first couple of figures. So there's actually a whole area of study of just healthy platelets that could be an entire paper or two on its own. And then next comes to the second point here. So what you'll notice is that we did a lot of RAC1. And again, that's because RAC1 is known to be very druggable. There's a lot of medications that are already targeting out there. It's very well studied. So that was why we focused on it. But there are so many other GTPases that we could talk about. I have RAP1 over here as an example. And that's an option that we could totally be going after other ones. They are harder to do with what we currently have, but it's still possible. Just within the time frame of the paper and what we wanted to focus on based on the drugs that we knew about, Aaron and I decided to focus on RAC. But again, so many more GTPases. And then finally, the other big point are what GEFs and GAPs does Layilin mediate? Now, GEFs and GAPs are what actually causes this switch between the active form of GTPase versus the inhibited form, or the turned off form. So the GEFs and GAPs, which are right here and right here, are what dictate the switch cycle. We were not able to find specifically what GEFs and GAPs Layilin is targeting, or if it's even targeting that. So that is, again, an entire other paper if you can identify what is mediating this on and off switch cycle. let me erase these just so that you can again see my pretty little pictures. So you can see, even after we finish the paper, there's a lot more to cover based on what we found. And now a new section. Shout out to my Patreon! Thank you so much! You're amazing! I can't do this without you.